Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the log-level model with interaction, we saw that percentage effects can vary with the z variable. Now we will go one step further and show that in a log-log model, the coefficient is an elasticity, a percentage effect of a percentage change. So what happens when the elasticity is no longer constant? And keep in mind, this is the most general case and the most common one in applied econometrics. So let's start with writing the model as follows. We're going to have ln of y being equal to beta 0 plus beta 1 ln of x plus beta 2 z, and ultimately beta 3 ln x times z plus an error term. Keep in mind here, you can imagine the variables here to be either the ones that we've been using in the previous videos or new variables, but for simplicity, keep in mind x is education, z experience, and y is income. Now, notice the interaction is between ln of x and z. So it's not between x and z. And that's the key difference from the log level case. Now, recall that the baseline interpretation is that without the interaction, when you have ln of y being equal to beta 0 plus beta 1 ln of x plus an error term, your interpretation was that a 1% increase in x was associated on average with a beta 1% change in y. Okay, and beta 1 was a constant elasticity, the same for everyone, regardless of the level of experience, and that was quite a strong assumption. So when you add an interaction, the elasticity is no longer constant, and we can say that the percentage effect of a 1% increase in x now depends on z. Keep in mind, in the log level case, a unit increase in x gave a varying percentage effect. Here, a percentage increase in x gives a varying percentage effect. That's the elasticity interpretation, and now that also varies too. So what if we applied the same concepts that we have seen everywhere with the differentiation, but now with respect to ln x? So if I had the derivative of ln y with respect to ln x, I'm going to have simply beta 1 plus beta 3z. Okay? Because the derivative, again, is with respect to ln x, all right? So if ln x is my unit, okay, I'm going to simply have, in the end, beta 1 plus beta 3 z. And this is the elasticity of y. So this is the elasticity of y with respect to x. But now it simply depends on z, as we have seen in previous videos, and every individual with a different level of experience has a different elasticity. In terms of interpretation, we're going to have the usual ones, but we're going to say a 1% increase in x is associated with y changing by beta 1 plus beta 3z, all of these percent. Okay, which means that if you have a z that is low in values, your elasticity is going to be a beta 1 plus a beta 3 times a low value. And if z is high, it's going to be beta 1 plus beta 3 times a high value of z. And if 0, it means that your elasticity is beta 1 for everyone, which means that you're back to the standard log-log model. Now, keep in mind, the interaction term is only adding something, again, when beta 3 is different from 0. In terms of real-world intuition, does a 1% increase in education raise income by a larger percentage for more experienced workers? Your answer is very likely going to be yes, in the case where beta 3 is bigger than 0, and the elasticity, unfortunately, will shrink with experience if you find out that beta 3 is smaller than 0. So same economic question as before, but now it's just framed in terms of elasticity, and the interaction term lets the data answer it. If we compare this model, so if to some to you the material in this video looks a lot and reminds you a lot of the log level model with interaction, keep in mind there is a slight difference in here, because in the log level with interaction, the interpretation that you made was that a unit increase in x led us to having a varying percentage effect. Okay? If instead, with the log-log model with interaction, you have a 1% increase in x, which again has that now varying percentage effect. So the difference is what kind of change in x we're talking about, from a unit in the log level to a 1% in the log-log. The interaction structure otherwise is identical in both cases. Now, why is this comparison important? Is because sometimes students do confuse log level and log-log interpretations in the interactions models. So keep in mind, while the formula in here, the beta 1 plus beta 3z appears in both the log level or the log-log with an interaction, what it measures is actually different, as you saw with the actual interpretation. The big conceptual takeaway for you from this video should be that interaction terms in log-log models allow now elasticities to vary across individuals, which is a very powerful tool because it means that the relationship between x and y is not the same for everyone. So in log-log interaction models, the elasticity of y with respect to x is going to be beta 1 plus beta 3z. It's no longer a constant, it varies with z, and because it's a log-log, it is in terms of percentages. In the next video, we'll apply this as a worked example and compute elasticities at specific values of z, so stay tuned and I'll see you in the next video.